and everything, I was thinking, well, what about if there's other chemicals that are floating around, and since there's nothing there to differentiate between the bad ones and the good ones, the bad ones are still able to float in and out of that sphere, right? And if the bad ones are able to float in and out of that sphere, then that would totally undermine the whole point of this origin of life theory, because it wouldn't be able to survive. It wouldn't be viable. It wouldn't be a viable explanation, because you have all these bad chemicals, right? I know I'm being condescending here, but it's pretty obvious. We have all these bad chemicals, and we have the good ones. The good ones are the ones we want in the microsphere, and the bad ones we want out of it. But the microsphere doesn't have the proteins necessary to act like little guardians of the sphere. They're not just standing there ready to bounce bad chemicals out, right?
When I first watched your video where you talked about bad chemicals, I just thought to myself, oh my, this guy is an idiot. How can I respond to bad chemicals? If you don't specify what a bad chemical is, it is impossible for me as a chemist to respond. Now I rewatched your video a short time ago and saw that you had made these little annotation boxes where you specify what kind of bad chemicals you are talking about. Tar? Is that what you're talking about? Tar? Seriously, man, tar? Oh, oh. Well, tar could mean a lot of things. It is not very precise. Usually one refers to a dark oily substance produced by wood, coal or peat. Since there wouldn't be any wood or peat before life began, we can dismiss that option. So we are left with coal and also the substance coal tar. Regardless, tar in whatever form consists of long chains of hydrocarbons. And coal tar is made of benzene rings, which are toxic and carcinogenic. Now, my master's and PhD does not make everything I say right by default, but they ensure me when discussing chemistry and biology I won't make a complete fool out of myself like you do. Tar! Well, let's see why. But first, a recap. So, we have our fatty lipids that look like this. This part is hydrophilic. This part is hydrophobic. It consists of hydrocarbons. The hydrophilic part likes to be in water. The hydrophobic part, which can be translated to hates water, does not like to be in water. So when we drop a bunch of these fatty lipids in water, they will form these microspheres. The reason that these microspheres form in water are just because of the hydrocarbons that hates water. They can't stand to be in water, so they spontaneously rearrange themselves in this bilayer so that they can be outside of the water. Here we only have the hydrocarbons. We have water here and we have water here. Now our nucleotide, which consists of a base, which is polar and likes water, a sugar, which everyone knows is soluble in water, otherwise we wouldn't have sodas, and a phosphate that is very soluble in water. So our nucleotide can spend its time both in the water and it can pass through the membrane and get inside the microsphere. When it bonds to other nucleotides, it will soon get too large to move out of the microsphere, and therefore we will trap these nucleotides inside. Now, if you drop your tar in this water, tar, the long hydrocarbon chain, well, since it really hates water, it will immediately aggregate with other hydrocarbons, and soon it will be way too big, and it will either float on the surface or drop to the bottom. It will not be able to penetrate the phospholipid, and even if a single hydrocarbon actually got to the microsphere, it would lodge itself in the hydrophobic part of the microsphere because it's hydrophobic. It will not go inside the microsphere because it hates water. It doesn't want to be outside the microsphere, and it definitely doesn't want to be inside the microsphere. If one of these hydrocarbons escaped from being aggregated with all other hydrocarbons, it would get trapped inside the microspheres by layer. It will not touch the nucleotides. And the benzene rings, well, they will just float on top of water. You know, when we have an oil rig that strikes a leakage, the oil floats on top of the water. It doesn't mix with the water. You can make a pretty basic experiment at home where you um, mix water with oil and just wait a couple of seconds, minutes, and voila, the oil will flow on top of the water. You see, your tar will not interfere with the nucleotides in the microsphere. I thought that was pretty obvious that, if you had any understanding of chemistry, that tar, which are hydrophobic, would not work that well in a water environment. So you see, I love how you were being condescending in that video response, talking about your bad chemicals. Oh, the stupidity of Npage85. Oh, you maybe got an A in chemistry and biology in high school, but you're not really qualified to talk about anything that has anything to do with chemistry. Tar? So, well, I'm going to link you to my YouTube Pornage Olympics video for Kaufman 666, where I demonstrate about that little story with the ball and the tree and it moves and the uh, hydrogen bonding between the DNAs. But basically, if you don't want to watch that whole video where I explain that the amount of heat necessary to break the hydrogen bonds are directly proportional to the number of hydrogen bonds both in oligonucleotides and in DNA. That's pretty obvious as well, and I explained that in that video. So, and it would be nice if you commented in that video where I left comments about peer reviews about intelligent design and how all the peer review articles are peer reviewed by philosophers instead of biologists, or biased by one guy even peer reviewed himself. That was pretty funny. Do you still claim that there are peer review articles for intelligent design? I would appreciate it if you responded to that as well. Well, let's see. I think that covered tar being damaged, harmful to the nucleotides in the microsphere. That was hilarious. I'm thinking about subscribing to your videos because I think you're one of the funniest guys on YouTube actually. I'm starting to think that you're a parody of intelligent design advocates because no one can keep being that wrong and that stubborn and that condescending and not realizing for 1 second that they are completely wrong about almost everything they say. Well, let's see if you're going to restate what tar is, or that could be hydrophilic in some way. Maybe you can draw the actual molecular structure of the tar that you are talking about. Obviously you're not talking about the tar I'm talking about, because that would be silly, right? So let me see how you're going to redefine and restate what you actually said and how this is a landmine with the tar, because I'm really looking forward to a video response from you. And well, until next time, why don't you look up a chemistry book and hydrophilic, hydrophobic, that's chapter 7 perhaps? I think you covered that in high school. It was so long ago I can't remember, but well, take care.